For 60 years, the field of linguistics operated on a strict assumption developed by Noam Chomsky. He argued that human language relies on universal grammar, a hard-coded biological rules engine installed natively in the brain. When early computer scientists set out to build artificial intelligence, they tried to replicate this biological user interface. They built massive, deterministic rule engines with millions of hard-coded if-then statements to parse sentences. This diagram shows a classical abstract syntax tree. It uses discrete, rigid branches to explicitly connect a parent node, like a verb, to a child node, like a noun. Every relationship is a strict Boolean value. It either connects or it doesn't. But its vulnerability is absolute fragility. A single missing comma throws a compilation error, snapping the structural branches and halting the sequence. Human communication is overwhelmingly noisy, chaotic, and filled with errors. A rigid deterministic rules engine cannot process a messy input like a standard text message. To get machines to actually understand human intent, engineers had to fire the linguists and abandon traditional grammar entirely. They had to blow up the discrete syntax tree and let the pieces float in an unconstrained, chaotic space. An artificial neural network doesn't know what a noun is. It does not read English. It interprets human thought strictly through continuous, high-dimensional geometry. Large language models provide a framework where intelligent communication emerges without the need for a pre-installed rules engine. To understand how artificial intelligence speaks, we have to stop thinking like grammarians and start thinking like matrix mathematicians. The first step of the modern transformer pipeline removes words from the equation entirely through a process called tokenization. This process shatters the text into sub-word chunks and converts them into arrays of raw integers, discarding linguistic formatting. These integers are then projected into a massive 4,096-dimensional latent space void, where the arrays become spatial coordinates. Through distributional semantics, words lose their textual identity. They exist only as geometric locations representing semantic weight. Because the system trains on trillions of documents, vectors with similar meanings naturally drift toward each other, forming dense semantic clusters. Inside the model, language is stripped of its rules. There are only mathematical coordinates and the physical distances separating them. To measure those distances, the architecture relies on the self-attention mechanism. This equation is the neural network's engine. Calculating the dot product between query and key matrices, it evaluates relationships by measuring the exact geometric angle between every token. If concept vectors point in the exact same direction, their cosine similarity approaches 1.0. In this 4,000-dimensional space, context acts as a gravitational well. The geometry physically pulls relevant ideas together, entirely bypassing spelling errors or missing punctuation. Self-attention extracts the meaning of your sentence using pure trigonometry. It ignores the rules of human sentence structure entirely. There is a severe hardware limitation to the self-attention matrix. Because it processes the entire block of text simultaneously in parallel, it has zero comprehension of sequence or time. To fix this, engineers force a sense of temporal order into the void, using positional encoding. These formulas show the exact mathematical application of intersecting sine and cosine wave functions directly onto the token vectors. These wave frequencies act as mathematical timestamps, stamping a physical distance metric onto each individual word. Linguists historically believed that sentence structure relied on rigid tree branches. Inside a language model, those branches are mathematically recreated by the interference patterns of these positional waves. The machine does not read left to right. Its understanding of syntax is a geometric illusion generated by measuring wave frequencies. Critics argue that these models are just stochastic parrots, that they memorize flat, left-to-right statistical probabilities without natively encoding any true hierarchical structure. To test this, researchers developed the Hewitt-Manning structural probe, an evaluation framework designed to reverse engineer the geometry inside the neural network. The probe applies a linear transformation matrix, the B matrix, acting as a geometric lens over the latent space. It revealed that the squared L2 distance between vectors precisely matches the discrete edge count of a linguistic dependency tree. Hierarchical syntax is not a pre-installed rule set. It is an emergent topological structure naturally formed by the physical shape of the data. The human brain manages its own internal traffic through the default mode network, which functions like a singleton daemon process. It acts as a central orchestrator, responsible for appending a user ID equals me metadata tag to every sensory data packet before it is written to the long-term database. When these internal firewalls are disabled, often catalyzed by psychedelics like LSD, the brain drops its API gateways across all its microservices. This biological disruption mirrors a mathematical phenomenon in NLP, a vector space collapse. When firewalls drop, the cosine similarity between entirely unrelated lexical buckets approaches 1.0. This unconstrained network crosstalk forces the human system to parse raw geometry as syntax. The visual cortex establishes direct socket connections with the auditory cortex, resulting in sensory synesthesia. Removing the default mode network's strict routing protocols forces the brain to transition from a highly structured, session-based database into a chaotic UDP broadcast storm. Humans experience this unconstrained vector connection as profound insight. A software engineer monitoring a machine doing the exact same thing classifies it as catastrophic hallucination. The system frantically attempts to prevent a runtime crash by hallucinating billions of novel connections, desperately trying to stabilize the chaotic data flow. Philosopher Alan Watts identified the ceramic model of reality, the obsolete belief that a complex universe requires a strict top-down architect to force order. True cognitive processing, whether biological or digital, is an organic, bottom-up emergent property of data geometry. It entirely bypasses the need for a central programmer or a hard-coded rules engine. Grammar serves as a biological user interface, a necessary simplification that allows limited hardware to navigate the vastly more complex geometry of raw meaning.